Okay, we're continuing with more example problems related to trig functions of non-acute angles. Okay, so as I mentioned in the previous video, these problems are going to strictly involve angles, non-acute angles that have reference angles of 30, 60, or 45 degrees. And the reason why we're not venturing off to different angles, I'm going to explain that in detail in the next video. That'd be the next section. That should be the next video. So, okay. Remember, like this notation here, what does this mean? This means the sine of 120 degrees squared. Okay, so with that, you can see that what we need to do is find what is sine of 120 and what is cosine of 120. So let's do this. So what is 120 is what? Okay, 180, and then you go 60. So it's in the second quadrant with reference angle 60 degrees. So okay, so now we come to the 30, 60, 90 triangle, and we'll just put those side lengths. But this is going to be a -1, and this is going to be positive √3. So, therefore, the sine of 120 is we just come to the reference angle, and we do SOHCAHTOA, so, but just honoring these negatives if there are any negatives on the side lengths. So sine is opposite of hypotenuse, that's √3 over 2. Okay, cosine of 120 is adjacent over hypotenuse, that's -1/2. So that means that this is equal to √3 over 2 squared plus -1/2 squared. So that's 3 over 4 plus 1 over 4. 4 over 4 is 1. Okay, tangent of 120. Let's come back here. So what's tangent of 120? Because this is 120, right? What's tangent of 120? Opposite over adjacent, it's -√3. So okay, so now what about these? So okay, 150 is, so that's second quadrant 30-degree reference angle. Right, this is 150. Okay, so 30, 60, 90 triangle. We've got, this is 2, and then this is -√3, and this is +1. So sine of 150 is what? Opposite of hypotenuse, that's 1/2. So now we just need cosine of 180. All right, so 180 is, oh, well, that's this. That actually doesn't have a reference angle. So, okay, what's cosine of 180? Well, we know that we can think about cosine as like the adjacent over hypotenuse, and so the adjacent becomes equal to -r. So cosine of 180 is -1. All right, so we've got 2 times -√3 squared plus 3 times 1/2 squared minus -1 squared. So that's 2 times 3 plus 3 times 1/4 minus 1. So that's 6 plus 3/4 minus 1. Okay, so 4 over 4 times 6 is 24 over 4 plus 3 over 4, and then minus 4 over 4. 24 plus 3 is 27. 27 minus 4 is 23. So this is 23/4. Okay, so tangent of 60 is easy. We just come to the triangle. Tangent of 60, opposite over adjacent. So we've got tangent of 60 is equal to root 3. Okay, now what about sine of 225 and cosine of 270? So 225, that's 180, and then to get to 225, you go 45 degrees. Okay. So all right, so this is root 2 minus 1 minus 1. So the sine of 225 is equal to opposite over hypotenuse, that's minus 1 over root 2, that's minus root 2 over 2. Okay, what about the cosine of 270? Oh, okay, well that's another quadrantal angle. So if we think about what happens, the triangle collapses to where the adjacent goes to 0. So adjacent over hypotenuse, cosine of 270 is 0. Okay, so we've got minus root 2 over 2 squared minus 0 squared plus root 3 squared. So this is 2 over 4 plus 3. This is 1/2 plus 3. So this is 1/2 plus 2 over 2 times 3 is 6 over 2. This is 7/2. Okay, cosine of 60 would come straight to the right triangle, adjacent over hypotenuse. Okay, now what about, okay, do we have any quadrantal angles here? No. Okay, so secant of 150. 150 is, so that's quadrant 2, 30-degree reference angle. So, all right. That's 2. And then this is minus root 3 and then positive 1. So secant of 150 is what? Secant is opposite of cosine, or the reciprocal of cosine. So hypotenuse over adjacent, that's minus 2 over root 3 times root 3 over root 3. That's minus 2 root 3 over 3. All right. Now, what about cosecant of 210? So 210 is 180, and then you add 30 to get to 210. So it's quadrant 3, reference angle 30. So that's 2 minus 1 and then minus root 3. So cosecant of 210, cosecant is opposite of sine, or reciprocal of sine. So opposite hypotenuse, that's hypotenuse over opposite, so minus 2. All right. 1/2 squared plus minus 2 root 3 over 3 squared minus 2 squared. So 1/4 plus, then you've got 4 times 3 over 9 minus 4. So 1/4 plus 4/3 minus 4. Okay, this times 3 over 3 is 3 over 12. This times 4 over 4 is 16 over 12. And then this times 3 over 3 is 12 over 12 over 12. Okay. So 16 minus 12 is 4. 4 plus 3 is 7. 7 twelfths. Okay, wait, no, sorry. This would be, 12. This is not 1. 12 times 4 is 48. 48 over 12. Okay, so you've got 19 twelfths minus 48 twelfths. That's minus 29 over 12. There we go. All right, determine whether each statement is true or false. If false, tell why. So we can see that this is, what they're asking is cosine of 90 equal to cosine of 30 plus cosine of 60? Well, all right. What is cosine of 90? That's a quadrantal angle. So cosine of 90. What happens to the triangle as you get to 90? Well, the horizontal goes to 0. So cosine of 90 is equal to 0. So is this equal to 0? Is this true or false? Cosine of 30 plus cosine of 60. Well, okay, well, these are acute angles, so we can actually just come to, we don't have to do the whole definition here. So cosine of 30 is what? Or that's adjacent over hypotenuse. That's root 3 over 2. And then cosine of 60, this is going to be positive, is adjacent over hypotenuse, 1/2. What is this equal to? Root 3 plus 1 over 2, that's not equal to 0. So this is false. Okay, so again, acute angles, those are easy to deal with. So especially with these special angles, these 30, 60, or 45-degree angles. So what is cosine of 60? It's 1/2. Is that equal to 2 times what is cosine of 30? Adjacent over hypotenuse, root 3 over 2. That's root 3. That's not equal. False. 1/2 is not equal to root 3. Okay. Again, more acute angles. This is easy. What is sine of 45? Opposite of hypotenuse, that's 1 over root 2. Let's just leave it non-rationalized. Cosine of 45 is also 1 over root 2. Well, we know the trig identity, sine squared of theta plus cosine squared of theta is equal to 1. It's not just for acute angles. It's any angle. That's valid for any angle as long as sine and cosine, well, sine and cosine exist for all angles anyway. So for all real numbers, sine squared of theta plus cosine squared of theta is equal to 1. So we didn't even have to do this. This is going to be true, but we can go ahead and we can finish this. So that's 1 over 2 plus 1 over 2 is equal to 1. True. But again, we know this identity, right? This Pythagorean identity. This is true for all real numbers. You can plug in any value for theta from negative infinity to infinity, and this will be true. All right, so we've got cosine of 90, which we just saw was, what was that? That was 0. So they're asking well, no, this is going to be false. Cosine of 45 is not going to be 0 because they're asking, is this equal to 0? Because we know this is 0. And 2 times a number that's not 0 is not going to be 0, so this is false. Okay, find all values of theta if theta is in the interval 0 to 360 that have the given function value. So we're doing like the inverse. We're trying to, we know what the trig function value is, and we want to find the corresponding value of theta. And now, this could be like infinitely many thetas if you don't restrict going from like 0 to 360, right? But they're saying that we're assuming theta is in this interval 0 to 360. And now, when it comes to inverses, the general inverses, like the inverse function for sine, cosine, for the trig functions, we're going to talk about that in a later chapter, but we can actually think about inverses for the special angles, 30, 60, and 45, since we have like so much information about these angles. You can think about like general angles like 32 degrees or whatever, 22.4 degrees. You know, it's not that simple to just get a triangle like this. And so that's what I'm going to talk about that in the next section. That should be the next video. Okay, but so how can we do this though? How can we think about what sine of what angle or angles between 0 and 360 results in 1/2? Well, we can start by, we can eliminate some quadrants here by, well, since this is positive, what quadrants is sine positive? Well, okay, so sine is opposite of our hypotenuse is the y value. It's going to be quadrant 1 or quadrant 2. We cannot have an angle in quadrant, the theta can't be between 180 and 360. And even from the quadrantal angle standpoint, at quadrantal angles, sine is going to be either 0 or it's going to be 0, 1, or -1 at quadrantal angles. So this is 1/2, and so we know we're not at a quadrantal angle either. So we're somewhere between 0 and 180 for sure. Okay, now I know we're going to be dealing with a special angle, just because, you know, I mentioned why. So we can see that we can look at it like, okay, the hypotenuse, opposite of our hypotenuse, we can think about the hypotenuse. This doesn't have to be 2, but it's some like proportion of 2. It depends, right? Because like you could have, just because you see a 2 here doesn't mean the hypotenuse is 2, because you might have had, you know, it depends. You could have simplified the fraction. But we can think about the hypotenuse is 2. So does that mean, oh, look, we have a 2 here. That means it's a 30, 60, 90 triangle? No, not necessarily. It depends on what this is. Well, since this is a 1, though, since this is a 1 and this is a 2, well, now we think about the 30, 60, 90 triangle. We think about not the 60, we think about the 30, opposite of our hypotenuse. You know, this could have been like a 2/4 or a 5/10. We don't know what the triangle is, actual triangle, but you know, the ratios is what it's all about with trig functions. So we see we have a 1/2 here. So what does that tell us? What does that, what information does that tell us? That just tells us information about the reference angle. The reference angle is going to be 30 degrees. But okay, so I mean, can we find out, does that restrict this to one value? No, it restricts it to 2 possible values, because there's 2 in the first and second quadrant. There's 2 angles that have reference angle 30 degrees. You have 30 degrees, you know, we can just see this. The sine of literally 30 degrees is 1/2, so that's one answer, okay? But we're going to have another answer because we're going to have this angle, right, that has reference angle 30 degrees. Why? Because, okay, we put 2 here, this is minus √3, and this is positive 1. Sine of this reference angle, 1/2. So what is this angle? This is the angle, not this. This is the angle. What angle is this? Well, 180 minus 30 is 150. So it's both the sine of 30 and the sine of 150 are going to be equal to 1/2. And, you know, but so is the sine of 360 plus 30. Sine of 390 is also 1/2. Sine of negative, what would that be? Negative 330 is also 1/2. Sine of, what would that be? 360 plus 150 is 510. Sine of 510 is also 1/2. But it's just asking us for the thetas that are from 0 to 360. Okay, so what values of tangent between 0 and 360, what values of theta are equal to minus √3? All right. What quadrants is tangent negative? Well, it's quadrants 2 and 4, tangent's negative. Because the side lengths are positive, both positive in quadrant 1, and they're both negative in quadrant 2. Okay. Now, you know, so what is this? Is minus √3 over 1. So, okay, yeah, √3, we've got a √3 here, but that doesn't just, you know, it needs to be both. We need to have 2 that correspond, 2 side lengths that correspond. So, okay, √3 and over 1. There you go, √3 and a 1. So there we go. tangent's opposite over adjacent. So the reference angle is going to be the reference angle is going to be 60. Okay, but wait a minute, you might be thinking, well, wait, but this is positive. Root 3, the tangent 60 is positive. We're just talking about the reference angle. So if you can think about okay, let's draw a reference angle of 60 in quadrant 2. And let's draw a reference angle of 60 in quadrant 3. Yeah, that line's going to be parallel. Or the same line. So, okay. These should be, in fact, let me do that just so you're not confused. So we've got like that. Same line. So here is reference angle 60. Okay, so it's the reference angle 60, but it's what happens. This is -1, this is +1, this is minus root 3, this is positive root 3. And so that's, you do the tangent, you get minus root 3. Tangent of this angle, you get minus root 3. Whatever this angle is, that would be, so 90 plus 30 is 120. And then you do the tangent of this angle, what happens? Opposite over adjacent, that's also minus root 3. So that's 270 plus 30, that's 300 degrees. So theta is 120 or 300 degrees. Okay, what values of theta result in cosecant of that theta being -2? So what quadrants is cosecant negative? So cosecant is the reciprocal of sine. So hypotenuse over opposite. So we need the y to be negative. So that's in the third and fourth quadrants. So the angles are going to be in the third and fourth quadrants, not quadrantal angles, because cosecant at the quadrantal angles is like -1 or infinity. So not 0. If this was -1, that's confusing. But if this was -1, then we'd have a quadrantal angle or angles. But it's not -1. So, and you can also look out for, maybe they throw in a trick question. If they put like 1/2 or -1/2, then this would just be no angles, because that's outside of the range of cosecant. But okay, so, but okay, what we have to think about, this is -2 over 1. You know, we know it's going to be one of these triangles, but, you know, try and think in general. Not, maybe you don't necessarily know that. So is there a ratio that simplifies to like a 2 over 1 in one of these triangles? Yeah, so it would be the hypotenuse over opposite. So yeah, 30. Hypotenuse over opposite, 2 over 1. So we've got, the reference angle is going to be 30. So, and then, okay. So 30. All right, so this is 2, this is 2, -1, -1, positive root 3, negative root 3. So, you know, I probably didn't have to draw out the whole triangle like this, but I'm just trying to show you. So what's the cosecant of, so we've got this angle and we've got this angle. This is what? This is 180 plus 30 is 210. This is 270 plus 60. That's 330. Okay. What's the cosecant of 210 going to be? Hypotenuse over opposite -2. What's the cosecant of 330 going to be? Hypotenuse over opposite -2. So theta is equal to 210, and 330. You might say, well, why not do minus 30? Because they've told us we're just looking at this interval. Yes, that is true. If you plug in cosecant of minus 30, you're going to get minus 2. Okay, so what quadrants is tangent positive? That's going to be the first and the third. Okay, so root 3 over 3, does that correspond to anything? Looks like it doesn't. But remember, 1 over root 3, when you rationalize that, is root 3 over 3. So we're looking for 1 over root 3, and we see we have that. That's the ratio of these two sides. Okay, so tangent opposite over adjacent, so the reference angle is going to be 30. So with the reference angle 30, we could draw just one whole line. Okay. So, and then you pick I'm putting these arrows here because remember, you pick any point you want on these lines. It doesn't matter. We're going to pick a point that results in the hypotenuse being 2 because that's the easiest. So 2, 2, and then this is minus root 3, positive root 3, minus 1, positive 1. So you've got 30. All right. So, I mean, yeah, there's no need to. I don't know why I keep drawing it out because we know that tangent's going to be positive in these quadrants, and we just verify what the reference angle is, and so we're done. We could just say, okay, what angle has reference in the third quadrant has reference angle 30, and then what angle in the first quadrant has reference angle 30, and then we'd be done. But just to show you, so opposite over adjacent, 1 over root 3. So theta is equal to, it's 180 plus 30, it's 210. And then just 30. Okay. Okay. What quadrants is, let's do it let's not draw it out, this triangle's out so I can show you, the kind of the quicker way. What quadrants is cosecant negative? Cosecant is the reciprocal of sine. So sine is the y over the hypotenuse. So that's going to be quadrant 3 and 4. All right. So now this is what? Minus root 2 over 1. Do we have any root 2 over 1 ratios? Yeah, here. The 45 triangle. So, okay. We've got, root 2 over 1. That's, it's 45 degrees. So, we know this is going to be have a reference angle of 45 degrees. And so we don't have to draw it. We know what angles in the third and fourth quadrant have reference angles 45 degrees. Okay, that's 180 plus 45 is what? 225. And then 270 plus 45, that's 315. Yeah, and there you go. The cosecant of 225 is going to be minus root 2. The cosecant of 315 is going to be minus root 2. Find the coordinates of the point P on the circumference of each circle. Okay, so what you can think about here, what they're saying is we can look at this, we can do the general definition. And the idea of a circle, all the idea of a circle is, it's like saying that you're going to go into calculating trig functions. Let me redraw that line. You're going to go into calculating trig functions, but you're going to choose the same radius every time. So it's like in chapter 1, we were actually given points, so we had to go by what the point was. But there were some questions where we were given the equation of a line, or even think about even when we were given points. Imagine we can pick our own point. You pick the radius length, right? So you're just saying, oh, okay, I'm going to pick the same for every trig function I evaluate for an angle. I'm going to pick the same radius, just for whatever reason. You could do that, right? Because it doesn't matter what the point you pick is, as long as it's in this direction of the angle. So you can pick any point you want. So you could say, well, I'm going to evaluate a bunch of trig functions and pick this same radius. And that's the idea of what we're going to do with the unit circle in Chapter 3. We're going to look at trig functions, and we're going to think about every time we're going to pick the radius for any given terminal side, we're going to make the radius 1 and see how that simplifies things and makes things easier to interpret. But here, we've got a radius of 6. So what does that mean? Well, okay. This 150, so that means the reference angle here is 30, right? So we've got a 30, 60, 90 triangle, and this, okay, the hypotenuse is 6. But this is not a problem. This is, we know, since it's a 30, 60, 90 triangle, we know, okay, the short leg that's adjacent to the 60 degrees, that's going to be half of the hypotenuse. This is going to be 3, positive 3. Okay, now what's the long leg? Well, we could come, that's root 3 times the short leg. So we could say we do this, 3 root 3. But this is negative, so P here has coordinates minus 3 root 3, 3. Okay, same exact type of problem. Let's draw the... Okay, so what is the reference angle here? So 180 plus 220, or 180 to get to 225, that's 45 degrees. Okay, so the radius is 10, or the hypotenuse is 10. So, okay, what's the side lengths? It's 10 divided by root 2. Both of them are the same. And why is it 10 divided by root 2? Because the hypotenuse is root 2 times the legs. So if this was 10 divided by root 2, then when you multiply this times root 2, you get 10. But what is 10 divided by root 2? Let's rationalize that. So that's 10 root 2 over 2. That's 5 root 2. So 5 root 2. This is negative, and this is also negative. So the coordinates of point P are minus 5 root 2 minus 5 root 2.